All right, I think we're ready to get started. Thank you everyone for joining us today for this webinar hosted by two of our HashiCorp solutions engineers, Vinny Ramirez and Lance Larson. Vinny is going to briefly introduce Consul and then talk about its prepared queries feature, which allows Consul to centralize failover policies across geographically distributed data centers. After that, there'll be a demo of geo-failover scenarios for a microservices that showcases Consul service discovery, Consul cluster federation, and Consul prepared queries. After that, we'll then spend the last 15 minutes or so of the webinar dedicated to a live Q&A with both Vinny and Lance available for questions. This webinar is being recorded, so if you miss something or you want to review, you'll be able to watch it again once we've finished processing and posting it, usually within 1 to 2 days after the webinar. When it's ready, we'll email it out to everyone who registered. So feel free to put questions in the questions box during or after the presentation, and we'll answer them during the Q&A session. So let's get started. I'll hand it off to you, Vinny.
Yep, sure thing. Let me come off mute. You able to hear me there?
Sounds good.
You're all good.
And then which screen, are you able to see my geo failover screen?
Yep, perfect.
And the CLI?
Yep.
Okay, awesome. All right, welcome everybody. Vinny Ramirez here. I am a solutions engineer at HashiCorp. And today we're going to dive into some concepts around Consul. My goal of this is to mainly help everybody understand what the solution is and why it exists. And then we'll get into some demos that involve microservices and some cool things you can do with Consul once you have it deployed. So with no further ado, let's hop into this here. And I kind of got a mixture of some slides I put together to help tell this story, and then we'll get into a little bit of the demo as well. All right, and I'm kind of toggling two screens, so be patient with me here. All right, so first off, people probably want to know, what the heck is a service mesh, and specifically what is Consul, which is actually pronounced Consul. And kind of the history of the name here is the solution was named after this highest level of government that you could hold in ancient Rome to be a consul and have direct report to the emperor of Rome himself, and a way that they actually, in a distributed way, were able to manage this enormous empire. So it's kind of fitting when we start to go into some of what the solution does that it's named Consul. So when we talk about Consul, I really like to try to help people understand that it's where it fits in the world of HashiCorp solutions. So one of the main benefits of Consul is how simple it is to deploy. So Consul is a single Go binary. It runs in either a server or client mode. And Consul provides support for very quick testing or training. You can fire it up with one command, Consul agent-dev, running on your favorite operating system, and you're up and running right away. So you can start to get a feel for the capabilities of Consul, work through some of our online training, and get acclimated to the solution very quickly is the point. However, when Consul starts to move into an enterprise setting or more of a production setting, the architecture will start to change a little bit, and we'll walk through what some of that looks and feels like here. So most people may not be aware, but Consul is actually a very mature HashiCorp solution, and it has been delivering value back to the development community and companies of all sizes for the past 5 years. Consul is a highly scalable and highly portable solution, as it can be installed pretty much anywhere into a traditional enterprise setting, and Consul has historically been deployed into private data centers or public cloud regions with the following architecture here. It's basically deploy some physical or virtual machines, get the Consul binary onto those machines running in the server mode, and then you form a Consul cluster. This introduces some high availability capabilities and a highly scalable solution at this point. So beyond that, Consul is then going to introduce support for the registration of services in a very platform agnostic manner. So by that, if we're talking about bare metal or virtual machines, they can be retrofitted or deployed, including the Consul binary, running in client mode. And then this supports the registration of services that are running on physical or virtual machines, but we also have the ability to integrate with schedulers such as Kubernetes and the various flavors of Kubernetes that are out there, from cloud native, roll your own, to some of the more proprietary versions of Kubernetes or vendor-based solutions, things like Red Hat. And then we're also doing some work with Pivotal Cloud Foundry in their non-Kubernetes scheduler as well for integration with Consul. And there's also some patterns that we have to deal with external services. So by that, things where you won't have direct access to the infrastructure that those services run on. So think like cloud native services. And then we also have some patterns to address serverless functions and interaction with the Consul cluster once you've started to build this catalog of services. So following that architecture of creating a centralized Consul cluster in a particular physical data center or a public cloud region, in an enterprise, you'll start to fan that out and deploy Consul into all of your data centers and all of your cloud regions where you're going to be hosting microservices. And then you can start to catalog and discover, register all those services into Consul. So this is a very different architectural advantage over maybe other service mesh solutions that can only be deployed into a particular scheduler or that solely focus on services running in a scheduler. So we've really got the full story of where services can start to pop up within an enterprise, either private data center or public cloud. So given the popularity of Kubernetes, HashiCorp is taking a lot of focus and has been working on ensuring that our solutions support Kubernetes architectures and workflows. So I'm bringing this up to make sure people are aware that HashiCorp is maintaining a Helm chart that provides support for really the two main deployment models that you're going to see when it comes to interacting with the Kubernetes cluster. And so beyond that, the main thing here is that we're after the services that are going to live in a Kubernetes cluster, finding out what those are. But really what's going on here is there's two main deployment considerations when it comes to Kubernetes and Consul. The first being that you can deploy Consul directly into a Kubernetes cluster, similar to what you saw in the virtual and server architecture. We want to establish a minimum of 3 servers. The Helm chart helps you do that by scheduling those onto independent worker nodes, and then we'll take advantage of some affinity logic to keep those from colliding with each other, since the servers themselves are representing the brain of that Consul cluster you're standing up. And then there's a couple other pieces to the Helm chart at a high level. We're going to schedule a binary running in client mode as a daemon set onto each of the worker nodes. And then there's also a sidecar injector service as well as a catalog sync service that gets deployed, and that stands up a fully functional, fully featured Consul cluster running inside of a Kubernetes cluster. The second approach to how you could potentially go about integrating Kubernetes clusters with Consul would be to use the Helm chart specifically just to deploy the binary running in client mode. So that daemon set that gets scheduled across the worker nodes, still deploy the sidecar injector service and catalog sync, but we're not in this architecture deploying Consul servers into the cluster. So this could be a favorable option if you're in an environment where you may have a number of Kubernetes clusters running in a data center or a public cloud that you'd rather sync and consolidate to a single Consul cluster that's managing that location, versus one-off console clusters and potentially dealing with the overhead of having multiple instances of console in a single location. So just the point of this is to kind of call out the two different patterns that could be followed and support whatever architectural needs the microservices and the solutions you're building throw at you. So the bigger story here, though, is that enterprises these days are just, they're not greenfield locations, and they typically have private data centers, multiple public cloud footprints that they're starting to figure out and consume. Various scheduler technologies exist in an enterprise. And most recently, Kubernetes has really hit the scene, and a lot of companies are starting to figure out their Kubernetes initiatives and strategies. The kind of the higher level of all of those infrastructure technologies is more this major shift into the microservices application model in and of itself. So take away the schedulers and the public clouds, it's more, we're starting to see the rise of microservices in an enterprise as well now too. And that poses a lot of challenges on the way things have sort of historically been run in a private data center, the certain consumption patterns of networking technologies and strategies can be challenged as microservices start to scale, and that's some of the things we're going to focus on today. But above all, it's the name of the game here now is we have all these microservices. We possibly are directly pursuing hybrid cloud architectures, as well as still managing the footprint of a private data center, and also looking at multi-cloud strategies or multi-scheduler strategies. So this is where Consul really starts to enter the story. So the main thing is going to be, as we first go about just the need to register and discover services, which actually is a problem that a lot of enterprises aren't necessarily focused on right now. A lot of emphasis has been put on getting into the microservices technology, developing some of these newer applications that can expand and contract and take advantage of public clouds and schedulers. But there's this sort of underlying problem that still needs to be solved, which is how will you keep track of these services? How will you network these services together when they have interdependencies? Or in today's demo, ways to approach this from a high availability standpoint and really ensure uptime of these applications that you're developing, wherever they may live. So that's quite a mouthful I threw at you there. So let's sort of combine this demo here and dissect some of what I'm talking about. And I think through talking through this demo environment that I prepared today, stepping through some of these services concepts, it might start to register a little more some of what's possible here out of the box with Consul. So let me explain this environment that I'm gonna show you for the demo today. In a call it private data center 1 or 2, I happen to be using Amazon regions for the sake of this demo today. And I really want to just showcase that what you're going to see is applicable to a private data center as much as it is to a public cloud. So what I've got here is data center 1 and 2, which is in my case, US East 1 and US East 2 in Amazon. And what I'm going to do first here is show you Consul. I'm going to fire up a couple of instances of a single microservice and register those into the Consul service catalog. And those are actually going to fan out into 3 different availability zones in public cloud, which would effectively translate to fault domain type of private data center architectures, like rack AB type stuff in the private data center world. So let's take a look at that real quick, and then we'll build on this demo and talk through a couple of things here. So if you've never seen Consul before, let me give you 2 distinct views here. It does ship with a user interface, and in this case, I have 2 different Consul clusters that I showed you, one running in US East 1, one running in US West 2. And what you're going to see when you first hit Consul is a list of all of the services that have been registered into it, as well as the health of those services. I'm actually, for this demo here, going to use a key value feature of Consul to feature flag what I'm going to show you today. So let's talk about that. I've got a basic user interface that the SEs here at HashiCorp use for demoing different solutions. And right now you can see that I don't actually have anything to do with service mesh or service discovery available to me in this web-based UI. So let's go ahead and use Consul and turn that feature on in more of like a modern A/B type of fashion, right? I'm just going to change this flag from false to true, save that off. And when I come back to my user interface here and do a refresh, I've just turned on this portion of the demo that we're going to review today. So let's hop into that. And so what you're actually going to see here is this is you can see some auto refresh going on of this. This is really meant to sort of a user view or a user interface view to visually see some of what Consul's doing under the hood with once services get registered and when we scale them and start to fail them here. Another view real quick to show you of Consul is we talked through the architecture. So if I'm connected to one of these, basically I'm connected to a VM in the data center or cloud region that has the Consul binary running in client mode. So I can check the status of Consul by doing a Consul members command. And we talked about that minimum enterprise architecture being 3 Consul servers running the binary in server mode, and then we start to have other forms of infrastructure starting to join this Consul cluster in client mode. So that's what's going on there. And then one other view to show you here is these 2 Consul clusters we're going to be demoing today are federated. So if I run this curl command, let me just clear this up to make it look a little cleaner. Run this curl command to find out what other data centers is this Consul environment aware of, and it's aware of itself running in US East 1, and then it's also federated with another Consul cluster in data center 2 or US West 2 in this case. So just wanted to point that out so you kind of get oriented to what's going on here. And right now we don't actually have any of the services I'm going to demo deployed yet. So we're going to deploy this microservice called the Profit app. We're going to do 3 instances in each location listening on port 8081 for this first iteration. So let's take a look at this here. I'm just going to kick off a script to do this. So as you can see here, this is basically just polling for that service I registered, and what we're getting back here is pretty interesting when we make that a little bigger. So we've got a view into US East 1 and West 2, or data center 1 and 2, and based on my architecture drawing, I just deployed 3 instances of the same microservice into each location. And Consul they're registered into Consul, and now Consul's just kind of fanning through them in constant communication with their health. And it's also aware of their unique IP addresses, the ports that they're listening on, and in this case, what availability zone they live in, or which fault domain they live in a particular location. So another view of this now, if I go back to my services view in each data center and search for that particular microservice, I can see 3 instances here in the first data center. And if I jump over to my second data center and also search for that particular service, 3 instances are available there too. So let's build on this real quick. All right, so then let me just make this a little bit bigger. So this is kind of the first challenge that a private data center may face when starting to deal with microservices at scale. So the idea of dynamic scaling of a service, so being able to just fire up large numbers of these. And so I'm going to scale this service in both locations, and I'm also going to introduce this dynamic ports instead of the static port 8081 that the first iterations of the service we're listening on. And we'll see how Consul handles that. And mainly it's kind of a story in bringing some of this newer microservice type behavior to a private data center, which could possibly strain or challenge some of the current practices of how load balancers are used in a private data center. Scaling an application may actually result in some type of human interaction or tickets or a person or process that's involved to update I rules and the pools associated with a load balancer that these may be reporting into today. So let's go back to this demo. You can see 3 instances in each data center right now. And what I'm going to do is just fire off my scaling event and see what Consul does. So you can see those services ticking up. And we're going to get just like a UI refresh as that happens. But we just took data center 1 to 17 instances of this microservice and data center 2 to 15 instances. And you can see Consul is still tracking the unique IP addresses at each of these services. And it's also aware now of these dynamic ports that these services are listening on as well. So that was just an automatic update to Consul, which is tracking the members of this service now. And that was just no ticket, no user intervention necessary to gain that capability. So let's go back to this. Oh, and then one more view of that. Let's kind of refresh our screen here. If I search the same microservice, I now have 15 instances in the second data center. And visually here, let's jump back to the first. And there are 17 healthy instances. So back to the story here, we just scaled our application. We did it in a very dynamic way that leveraged the automation that Consul brings to the story here and brings to the private data center. We didn't have to get anybody involved yet, right? So now let's kind of zoom in on just one of these data centers and talk about some failure scenarios, since that's what we came to learn about today. So let's picture we have another microservice in one of the data centers that's called the I want what you're selling service, and it needs to find a healthy instance of the profit service, which are the services we just deployed into Consul. So, Consul has a couple of ways that it can help fulfill that request. Consul does come with a DNS service out of the box, a Consul DNS service that can be consumed. And then there's a number of libraries or SDKs that also support programmatic consumption of Consul's API. So you got 2 different distinct paths to pursue this. But in the simplest terms, this service is going to look for a healthy instance of the profit service. Consul will just do a basic round robin of the services it's aware of in its location and return that request. Establish a route to the service on behalf of the other service. So now let's start to talk about these failure scenarios. So first off would be, I just lost a handful of the instances of my service. So, what's Consul going to do there, right? And a pretty obvious move, but if you're in any way familiar with local traffic management or load balancers, is that's going to be detected by Consul and just the regular polling it's doing of the service, and it'll immediately remove those services from its catalog as being healthy or available to route traffic to. But it's also tracking what instances of this service are available, so that if there's retries from my service or new sessions coming in, it knows exactly where to route those within its own geographic location. So next failure scenario, similar story here. We're starting to lose services, and another part of the story is this is actually going undetected by our application, but Consul can also help an operations team detect that things are going on in the data center or the infrastructure. So we can, there's a number of ways that you can consume what Consul's aware of and possibly alert an operation team ahead of time. Hey, there's something going on here. Somebody needs to look at this because we just lost instances of our service in 2 areas of our data center or 2 different availability zones in a public cloud. But what Consul is going to do for you is, again, it's going to detect that that's happening. It's going to stop routing traffic to unhealthy services and continue whenever possible to route requests to a local instance to answer that. So The next real phase of this failure that I'm going to hop over and demo for you is what happens now? What happens if I've just lost all of the instances of this Profit App service that my other service needs to talk to in a single location? What's going to happen now? What can Consul bring to this story? So let's take a look at that. Again, we've got a graphical view of these services. Let me pull up the instances that live right now in this West 2 data center. And I'm going to go ahead and just do a hard down of the second data center. So let's do a drop of all of those services. And then just from a graphical standpoint, I do need to refresh my UI and search again. And no longer are those services there. And if I hop back over here, let me just rewind what I did. Let's bring those back. In this view now, if you remember, we're examining Consul's ability to see the different instances in each geographic location. So we started off with 17 in data center 1, 15 in data center 2, and now we're going to do that hard down motion. And keep an eye on the right corner of the screen, US West 2 here, where we're going to drop those 15 services that are online. So it happens really quick, but what Consul just did is it detected that. And now in US West 2 or data center 2, if I want what you're selling, microservice trying to reach the Profit App, I reach out to Consul and it knows if you need to get to one of those services, there are none of them healthy in the data center you're in, but there are 17 instances of it in a neighboring data center. And it is then able to route that call to the neighbor. And this is an automatic detection and failover capability that Consul is providing out of the box. There's no user intervention or anything necessary as long as the networking is in place and these clusters are federated. We have this capability. So another part of this story then is what happens when I bring the service back. So right now, Consul's aware of this. Again, there are no instances running in my US West 2 or Data Center 2 location. And if I hop into Data Center 1, I do have the 17 instances. So bringing the service back online could also pose a challenge in a private data center where we don't necessarily have all of the same levels of automation to update, say, a local traffic manager or iRules and things like that. So let's bring this back up. Take a look at what Consul does for us there. You watch the right side of the screen, we'll get a refresh here. And Data Center 2, US West 2 is now back online. We've restored the 15 instances of the service that run locally now. And Consul will then be able to start routing traffic locally where it belongs to keep, the services online. And, maybe in this previous instance here, and let me just show you that view real quick that we did bring the service back in Data Center 2. You can see graphically that those 15 instances are back online and healthy. And let's just talk about what's going on here architecturally. So you saw the loss of a service in a single data center. In my demo, it was actually Data Center 2. And Consul was able to detect that. And the scenario we're talking about here isn't a full-on loss of an entire data center smoking whole. This is a granular failure of some services. But if these are critical services that make up a highly critical application that's delivering value and business, money or transactions or some type of service back to our business, and this can be quite the challenge to deal with in a private data center for a number of reasons. So the fact that this is all taking place automatically and Consul's able to route to a neighboring data center provides this level of protection in a microservices architecture where I may be down in one data center, my application's not down. I may have some degradation by reaching off to the second location, maybe not, depending on network topology there and the latency. But even if I do have some degradation, this is always favorable over the complete loss of a service or being hard down. And I also pointed out too that when the services were restored, there's also that level of automation that really no action is necessary to bring that back up. No humans had to get involved with that. Consul just self-healed and said, we're now back online and we can start to reroute traffic locally as needed. So some of those concepts I'm trying to illustrate with this. So one more failure scenario here is, so what happens now? So we're only talking data center 1 and 2, and now we've lost the Profit app service in both locations. So, hey, maybe this is now time to update your LinkedIn and start packing up your things. And all joking aside, the reality now of, and sort of the allure of microservices is we can start to build applications that are resilient enough to take advantage of this type of a geo failure pattern that Consul's able to bring by first being able to register those into Consul, federate with other data centers that are running other copies of the microservice. And then we really get into just architectural decisions around the types of SLAs that need to be delivered back to the business, the type of uptime that the HADR and business continuity strategies need to be architecting towards that could drive decisions around running the microservice in the private data center, as well as extending to a public cloud as part of an overarching uptime strategy that ensures the loss of 3 data centers, 2 data centers, and number of data centers. This depends how aggressive you need to get there. But also doing this in a very automated way that tends to challenge more so the private data center networking world than the cloud world. So a couple key concepts here with that then. The kind of magic underneath the hood that you're seeing where Consul's aware of the services, but more so when I fail the services, that there's services somewhere else. Just do that one more time here. Let's drop that right side. What we're seeing here, this is a concept in Consul known as prepared queries. So let me just explain that real quick. There's really 4 methods of interacting with them. Once you've first registered your microservices into Consul, you can then start to build these, either the first iteration may be static lists of failure orders. I know that this service runs in data center 2 or cloud region X or whatever the case may be. You can script that order and tell Consul where to go in case of an emergency. Preferential failover maybe based on knowing the service is actually there and how you fan that out in your enterprise. The next method would be more of a dynamic policy that uses round trip time in Consul, which is just it's able to detect what is the latency. Let me choose the shortest path for you. There's a hybrid mode of this where you can mix the round trip time logic with then a very specific list of data centers to look for. And then the fourth method here is this prepared query template concept, which is really more of like a wildcard strategy. If you're already down the road with a lot or proliferation of microservices, you may not really have all the right people or decision makers to script a very specific failover pattern. So you may just want to wildcard that out and say, you know what, you're federated with some other clusters. If you find this same service, sure, I'll take that over downtime. So I do have a link here. We can share that out with the notes from the webinar. We have some Learn resources to help reiterate this concept here of what these are. And we also provide some examples that sort of build up the prepared query logic of how they're written. First, from registering a service to then, this is more of that specific failover order, go to DC2, then go to DC3. And then examples of the round trip time logic, which is a nearest n, and you define a number of different data centers for Consul to look at. An example of that hybrid policy, use shortest hop first, then start to go through my list of the data centers I want you to look. And then this is that prepared query template example I was talking about, where you can really start to wildcard like all of your services or certain sets of services based on a couple of variables you can search for. So this is a resource for anybody who's interested in that. I'm trying to keep true to the time here. And just finish up this content. I did want to explain really quick then how this ties into the overall service mesh story according to HashiCorp and according to the Consul solution. So a simpler way that I like to describe what is a service mesh to help people just quickly wrap their mind around it is it's the what, where, and who of services. By that I mean the what is what services are running, what is their health status, and what happens if they do go unhealthy. The where is where physically, geographically are these services? What data centers are they in? What clouds are they in? What schedulers, which Kubernetes cluster, whatever the case, where are these services? And then the third, the who, is not covered in this webinar. This is more tied to our security capabilities in Consul, which were introduced with the Consul Connect feature. And that's really the who of services. It's service to service, who can talk to who, and it's really an auth N, auth Z story where we have some pretty cool stuff going on with mutual TLS that we in no way covered today. And the reason I chose not to do that is really trying to help people understand that to get started with a service mesh, really the most important thing and problem to approach is service discovery, which is the what and the where. And that's actually going to gain you the capabilities you saw today. Deploying Consul into your different locations, registering services, building a catalog, then federating that with another location out of the box. Now you're going to be able to explore this prepared query feature that you just saw. And the other point I want to make is if you don't have service discovery and all of these services built into a catalog, you're not really going to get into the service segmentation, more of that security play, the Consul Connect, use of Envoy and sidecars, and we have a lot of examples of that out right now, but just trying to get the word out on like a good crawl, walk, run approach to where to even start with this. So just kind of the challenge back to myself when I created this content was I set out with this to try to explain like why do we need a service mesh in the first place? So really the world we're living in now is we've got all sorts of infrastructure, especially if you're a large organization that's been around for over the past 10 years and wasn't born in the cloud. So you're dealing with bare metal, private data centers, hypervisors, now the onset of public clouds and multi-cloud strategies, as well as the various schedulers that have come along the way. And all of this is just infrastructure that our microservices can now live on. So why do you need the service mesh? Because you have to know where are all these services? How do I start to rationalize that? Build a catalog, introduce some cool stuff like prepared queries and automated failovers. These are very good places to begin with this technology. And Consul really introduces a very vendor agnostic, infrastructure agnostic, cloud agnostic approach to this problem. So that's pretty much the content. Just want to bring back the Consul, who I think may have learned a little something about service mesh today. And I think we can start to open this up for some Q&A if there's any there.
Yeah, thanks, Vinny. Great demo. All right. And we are going to open it up for questions now. Feel free to enter any questions in the questions box, and we'll try our best to get to all of them.
Yeah, absolutely.
So the first question for you, Vinny or Lance, who is here now with us answering questions as well. Common question, how much of this information is applicable to the OSS version versus the enterprise version of Consul?
Yeah, actually everything you just saw in my demo of federation and prepared queries is an open source capability. The one sort of heads up on this architecture at any degree of scale, let me just back up to a slide to help just quickly answer that. When you start to get into like multiple locations and federation of a console cluster, there are some enterprise features that help with some of the network noise and traffic that can go across the wire in the open source world. So that's just more of a heads up at scale, but this is definitely all possible right now in the open source.
Great, great. Next question, how do you federate between two console clusters? What are the steps?
Yeah, that is a very great question. Let me actually try to drop these into the chat, but I pulled that up. We have a learn.hashicorp.com site with a number of self-service, just free to consume guides that reinforce these concepts that can be just run in most cases on your own laptop or whatever the case may be in the open source. And then we also have some tracks that will focus on enterprise if you are an enterprise user of some of our solutions. So this guide right here actually goes over the concepts of federation in Consul, as well as actual examples and commands of how to do that. So let me go ahead and drop those into the Slack. This wasn't really a working session demo or a webinar. We only had so much time to cover the content, but the cool news here is a lot of this is just out there when you have some time to dig into it.
Great. And then another question, the term prepared queries, is that an out-of-box feature for Consul?
Yeah, absolutely. I mean, it's out of the box as in it's a capability that can be consumed as you start to register services. And the other link I'll post right now is to a guide that explains those 4 patterns of prepared query today.
Okay. And the next one, is Consul Connect part of open source Consul?
Yeah. And the answer to that is yes, it is actually. And the key point we were trying to drive today was that you need some services discovered and registered in your catalog before you can start to even use the Connect capability. We have some pretty cool guides on that as well. Let me find one, or Lance, if you could help me out with maybe one of the instruct links to post in here. Some of the easiest ways to get started with Connect, if that's a feature you're after, is to follow some of our guides. We have a new learning platform that we're starting to adopt that can host a Kubernetes cluster for you. A scheduler tends to be a pretty easy sandbox to start to see some of the Connect capability, because the ease of firing up a sidecar and an Envoy in a very easy to consume programmatic way versus some of the challenges of even getting a Kubernetes cluster or some other type of scheduler stood up to start to use that.
All right, next question is, I know that the person says this wasn't a Connect demo, but how does Consul Connect integrate with prepared queries for failover requests?
Yeah, Lance, do you have some high-level thoughts on synergies there?
I just put it in the chat, Vinny, if you want to bring it up on your screen, the service resolver entries.
Let me grab that.
And then for the last question, Vinny, if you want to click on the instruct track in there, just if you want to pull that up for the folks.
Yeah. Let's get that going.
We can.
Good job. Yeah, let me tie that one off. So this link here on this instruct learn platform, this is very Consul Connect specific, and there's some guided exercises that just within your own web browser that you can walk through and follow some of these guides to really start to understand those concepts. And then back to service resolver.
Yeah, so I think there's actually a call out in there to prepared queries. So obviously Envoy has some more advanced capabilities when it comes to traffic management that can be sort of managed at the layer 7 level. So a lot of the different types of entries in this type of resolver, filtering by subsets of an application version, redirecting traffic to different DCs, failing over between DCs. These are all types of configuration entries that are very specific to our layer 7 routing capabilities in Connect, but in the same way that Vinny was structuring, prepared queries to balance traffic across multiple data centers, you could do that with our layer 7 traffic management in Connect. It's not the exact same type of configuration entry, but it's very much in the spirit of prepared queries, and Envoy having, again, more advanced load balancing capabilities outside of just round robin, that Vinny was showing, is a way that we can kind of tap into the power of Envoy, but sort of do it with more fine-grained capability, with the same general idea, right, of being able to kind of seamlessly reroute traffic across failure domains or WANs, right, joined east-west data centers, as kind of like an advanced type of prepared query with Envoy. So good question, and these documents should give you some starter types of configurations that you can do to get similar functionality with Connect.
All right, the next question, let's see. This is kind of a leading question in that do people create their prepared queries and then consume them from the Envoy proxy for Connect?
So the story that Lance is telling, we're kind of confusing two concepts a little bit. And once Connect is in the architecture, that's where Lance is sort of directing the conversation to this emerging pattern that is being introduced in that world of the service resolver pattern of it's a little different than prepared query, but very similar. So prepared query has been around for quite some time, even prior to the introduction of Connect. So being able to do what you saw today without the mutual TLS part of the story. And then there's a little more to the story now as we start to climb the layers up to layer 7 with things that Envoy integration is introduced and a way to consume that. That's sort of building on the history of what prepared queries have done in the past, but it looks and feels a little bit different.
And next question, how do I visualize my ingress traffic with service mesh? Traditionally, it was sort of, say, CDN to DNS, F5 GTM, F5 LTM web services.
Yeah, you want to take a swing at that one, Lance?
Yeah, so I'd say, again, we're not really focusing on Connect in this webinar, but we are looking at visualization capabilities for Connect, actually similar to what you might traditionally see in other meshes. So I would just keep an eye on that.
Yeah, and actually, Lance, we kind of hit some of that too with this instruct lesson, where there are some examples of using like integration with Prometheus and Grafana and some of those newer ways that people are dealing with service visualization anyway. It's not necessarily going to address that view all the way back into a private data center, but there's it's more honestly a conversation we're really starting at HashiCorp to have with the networking teams now, where historically Consul's been more of viewed as like an application developer type of solution, and really we're trying to help people understand that this story actually impacts the network team the most in an enterprise, and there's patterns and strategies with this now that are going to sort of evolve over time and through working with some of the larger enterprises of the world as they start to look at managing microservices at scale anywhere. So definitely stay tuned on that, and I'm sure we'll have some more updates as well as that story unfolds.
All right, is Service Resolver on Consul 1.6 version? Is it on 1.6, the Service Resolver?
I think it's beta right now too. So
yeah,
Go
You
ahead.
go back to that document or just that configuration entry. Yeah. So this is in the, I don't think it calls it out there, but this is in the latest version of Consul, which is the 1.6 beta.
Got it. And hey, appreciate all of the Console Connect questions. Just curious if we had any that were more, if I go back to this sort of frame up that we're trying to educate people on is, Connect is a total leap on the far right here to, service security versus the where you need to begin with service discovery and what we saw today. So, but I love it. I love the questions, and just curious if we had anything more based on
Yeah,
the presentation today.
it looks like, are there differences from open source federation versus enterprise advanced federation in Consul?
Yeah, that's not really what I was trying to point out. Let me pull this up real quick.
Yeah, I mean, there's a couple things there that are just sort of the main one is, so in open source, the console servers all require a sort of full mesh between data centers. So that requires, let's say you have 3 console servers in data center A, 3 console servers in data center B. You would need to prevent flapping and clusters reporting that they're actually unhealthy or unavailable when they are. You would need there to be full connectivity between all those servers. For requests to the other data centers, those servers do RPC calls to the other DC, and then to secure both that RPC traffic and the you need to secure both that RPC traffic and then also the WAN gossip traffic, which is managing potentially another gossip key ring, one for your LAN and then one for your WAN. With the advanced federation, you don't actually need a full mesh between those servers. You can actually create pairs within the data centers that can talk to each other, and then that can just be secured with TLS over RPC. You don't actually need to manage a gossip keyring for the WAN traffic when you're using advanced federation. So the benefits of it are, again, you don't have to have full connectivity of the servers. You can create pairs that are supposed to actually be able to communicate. If you have kind of a hub and spoke model for your data center that's extends out kind of across your WAN, this is a good feature to map to that. And from a security perspective, you no longer have to worry about securing that gossip traffic. And you don't really want that unencrypted, because then people can figure out where your servers are and potentially mount some attacks against those. So simpler security, easier to map into more enterprise networking topologies. But by and large, the same sort of underlying connectivity between the servers is the same. It's just how you can secure it and then how you can create those relationships that differentiates the open source versus enterprise federation. And then Vinny, I think you had more of a that's kind of the technical part of it. I think you had more of a functional.
Yeah. I mean, I was just going to point out, I mean, we're not here today to get into enterprise. This was an open source demo that you saw, and a zoom in on some open source capabilities of Consul. Really trying to educate people in really back into the private data center of the existence of the solution and where it really fits to try to solve microservices popping up in your traditional networks and your traditional data centers, and the problems that you may not be seeing yet, but potentially could be starting to brew, depending on work that's going on at maybe at another team, at different application projects, et cetera. Just a quick shout out to enterprise features. These are today just public facing on our website. If you drill down on the Consul enterprise features, a lot of them are more focused on the scale of a Consul cluster. So when we get back to in management of that, so when we got back to that architectural approach I was talking about in the very beginning, that in an enterprise, you're ideally with Consul going to start to fan out and stand up Consul clusters per data center, per region, and you could have a very large environment registering in and participating in a Consul cluster. And we even have some pretty impressive Consul cluster numbers with number of members out there in the wild today that range up to like what 40K plus clients, Lance, if I'm correct. And when you start to get at that scale, really a lot of our enterprise capabilities are around the support of operating at that scale and the management, the operational management of the cluster as it grows. There are more enterprise features around the corner here that we really can't talk about in this webinar right now, and they're not being publicly announced yet.
Great. And just time for a couple more questions. What is the biggest advantage over F5 8 rules / info blocks?
All right, so I'm not going to profess to be like a traditional F5 IPAM guru here, but this slide even helps to reinforce that when you're in the private data center where you actually have control over a lot of these solutions, like your entire fleet of load balancing technologies, physical or virtual, your IPAM solution, et cetera, your DNS effectively. Those things have traditionally been managed in a private data center, but what happens when you get into the public clouds or into these schedulers is you lose a lot of this, or a lot of the visibility or control over that potentially. So you aren't really in control of DNS in a public cloud. You're not even necessarily in control of it in a Kubernetes cluster. So what the advantages here of using Consul is you now have the ability to bring your own DNS if you so choose, or there's also I mentioned before, supported libraries and SDKs that can consume the service as well.
Yeah, and Vinny, just to add to that point, so I put in the chat just specifically around the F5 if you want to bring that up. So in terms of kind of actually making F5 as a product actually does support service discovery, and Consul is one of the tools that can be used to actually update F5 with node pools that actually get updated by Consul. So if you had sort of an application stack, maybe you were pushing out Nginx and then some stateless apps, and static content behind that, you could actually push that all out with Terraform potentially and have Consul updating your F5 dynamically. So I would say that there's certainly some areas where maybe Consul or service mesh would make more sense than having a more traditional load balancer. But there's a lot of cases where these products can be extremely complementary, and one of them is in the same way that we showed, Vinny showed us pushing out new applications and those actually getting registered within Consul. That's information that F5 could actually use to update its node pools dynamically to, again, sort of reduce downtime and accelerate that application delivery process. So there's another webinar that we're doing here in a couple weeks with F5, a joint webinar that's going to showcase some of that information. So if you're interested in kind of bringing more, cloud-specific patterns to your on-premise data centers, with F5, or you're taking F5, into the cloud because you have a lot of operational experience with it, this would be some great content for you to check out.
All right. About at 1 o'clock right now. I think we can fit one more question in quick. What is the simplest way to get started with prepared queries? Was it that demo that you just showed us?
Sorry, I went up on mute. The simplest way would be to start taking a look at this Learn guide that I did post in the chat, as well as if you just kind of scroll back to all of the Consul tracks, right? So depending on, it literally will help you from just download the binary and fire it up in a sandbox environment and start learning just more about Consul in general. But yeah, there's that specific track that will cover the concept of a prepared query. The challenge with that on your own would be creating some type of dummy services to register and if you want to use your cloud account and do like a data center 1-2 type scenario, things like that. The demo I presented today is not very easily shared publicly right now because it's part of sort of this more monolithic demo stack that we use as HashiCorp SEs, but that's something we could probably work on stripping out. And this instruct platform that we're sharing some of these self-guided exercises could be another avenue that we're starting to enhance, where we can get more stick time on some of these concepts without having to have early access to even cloud credentials if you wanted to start to learn it. So that's evolving, but I would say definitely start with our Learn platform.
All right. Well, thank you, Vinny, and thank you, Lance, and thank you to everyone who submitted questions. And Vinny and Lance, thanks for the great answers. I hope everybody enjoyed today's webinar and has a better understanding of Consul now and how prepared queries can help you build more resilient architecture infrastructure. For more webinars, you can visit our website at hashicorp.com/events. And if you want to view an archive of our previous webinars, you can visit hashicorp.com/resources and filter by webinars. And finally, as I mentioned at the beginning, the webinar was recorded, and we will make the recording available on the HashiCorp resource library after processing, typically within a day or two. We'll also email a link to the recording for everyone who registered. So have a great day, and thanks so much for joining us.
Thanks, everybody. Have a great one.